So I had thought about this before. Um, it's a difficult one to talk about just because you kind of need to know the differences between a couple of really fundamental quantum physics stuff and more if you want to be able to maybe understand why I will say it's this thing versus another thing. If only because even though it's mimicking another thing, it's not doing that at all. It's the way to describe it, sort of, so to speak. So I created this concept idea a long while back, actually, very long while back. I haven't talked about it, I think, very much on my YouTube channel. I think maybe once at most. So, uh, but the basic premise is a multiple like LED laser diode kind of setup, right? In an array, like a phaser, but it's like not really. So there's going to be a lens, like a Lorentz lens, but I can't use that, and I need to have destructive and constructive interference, and I need timing from the rear to the front as it will fire as a laser to be able to do this. And it has to do it in a very uh, it can't be constant. Let's put it this way: I'm modulating a constant given amplitude frequency. So it's like, let's say it was at 1, it would go up to 1.5, then it would go back down to 5, that kind of thing. So it's like the overall luminosity would be what is going on there in terms of brightness. All right. Now, the ease and simplicity of this idea is as a result of not needing anything in terms of like much for lenses, which is the big part, and then being able to have this suddenly output a lot more power than it would normally otherwise, as if I just made them really bright and then stuck them together nearby and then made a bunch of little tiny lenses into a bigger, more focal, array of lenses. This would be more compact and use less energy, waste less of it to heat, and be able to deliver its energy on target more effectively uh, with less distortion. Okay, so there's a lot of stuff that makes it better effectively than something else. So we'll first start off with the basic concept and premise is because I'm going from rear to forward, then from out to in, and a somewhat in to out, with the way I use a constructive and destructive combo of interferences for these wavelengths of light, how it is I have them bend with the given lenses and the reflectional properties of the mirrors. Okay, so there's only certain wavelengths that we can use. As a result, I'm able to force a virtual particle pairing effectively that allows for the given photons here to have that exist behind, and then it doesn't, because then it'll tunnel forward in front of it, and then it'll use that as a collapse sort of thing forward, but then it'll keep its information and then make another, as it kept that information, virtual particle that stored what is the equivalent of a polarized light, many different polarized lights actually, and a Unfortunately, larger amount of kinetic information. Okay, so kinetic is a weird one because, you know, why? It doesn't have mass. Well, kinetic to us will mean more thermal dissipation, meaning our impact or transfer, that kind of thing, thermal dynamic stuff, you know. But for what this really ultimately is doing is the opposite of what most quantum standard model mechanics would have you believe. We're not superpositioning, we're not entangling. There's no pairing practically. In fact, the front particle and the rear particle, uh, well, they were always there. Kind of put it that way. They're both always in between the wavelength of photons. So, like, a good way to describe that is using the destructive properties to elicit a constructive pairing of a virtual that acts as if it took this polarizational and this constructive and put them together. And now it happens to become entangled, but it's not entanglement. You know what I mean? Like, there's no entanglement. You can't be entangled because of that sort of effect going on. And then it can't be in a superposition because it's not ordered. It's too chaotic. You see what I'm saying? Like, none of them could use those words. Whoever them is in terms of the physicist or comment section, really. It'd be a bunch of people that would think they know something, and it sounds like this, and that's because I'm describing it like that. I effectively attached a field to protons. That's effectively what I'm really doing, and I'm making virtual particles exist as the field information. Then they exist as these other things that are not there, don't exist, and are simply not a thing. And then they travel with the field that is now attached to the photon and its wavelength and all the others. All right? Which means it compresses a lot more of its given information into all the wavelengths and protons. In no way, comment section, remember to write photons, please. You gotta write photons. They're the non-mass light particles that we use that are wave, light, particle wave duality particle thingies, and so on. But since we already have a field that is already attached, but we almost never use it, I learned how to take a quantum effect, which is what this would be, and use it to my advantage. So as it moves through, because of course there's no electrons, but you know what photons are made out of? Something that produces a field that shares information, all right, between when they go through, when they entangle, when they split, what they've done, so on and so forth. There are multiple fields here, all right? And so a light field that collapses during the destructive process that then has a polarizational, almost superpositional brief moment no longer wants to collapse into a destructive and has no information value field. So it stores that information in the preceding constructive interference model along with the pulses that are going on here in the phasor lens array. My dog wants to play fetch. So this is a real delicate topic because people will argue like stupid, just stupid levels of argument. It's like, this is my principle, this is my math, this is my effect, these are my things. I know what this is, you don't. So if you're going to argue with me, then it's like, well, effectively, you're arguing with the very person that for sure knows. And you're not that. You're not that person. Which we all have seen this, and maybe not all, but a good number of us have seen the post from a person who wrote a book on the very subject this person was trying to debate them over, and then told them to read the book they wrote, which is essentially what these people would be doing. So I'm going to move on because it's like, all right, so let's just get rid of that. All right, we'll remove the Lemke principle and we'll just make it a phasor lens that, using a destructive and constructive interference model, it happens to be able to focus with a little bit of mirror effect too, incoherent, a bunch of light into a laser that happens to be very well defined and consistent in its overall size, and will be much easier to dynamically alter within a given area within the size of diodes and more, the angle and focal length of the laser with much less wasted heat energy, and so it can be much more powerful and perform the same functions, especially with modulation of the amplitude, meaning luminosity pulses, while still on at all times, allows for a consistent effect, which we've seen before, yes. Maybe not to that level of degree in terms of directionality of a phasor, like it's a phasor array, and then a focal lengthening and shortening in a given area, of course, and with multiples, with the correct reflection and pass through, gain an even greater increase of this effect, like a Wi-Fi hopper. And I can now use much lower watt lasers, much less powerful, to achieve, like I have, a much more powerful laser, higher watt type of effect. All right, the Lemke principle is the caveat. So it's like there's not so much spin, although spin is involved. You have to get involved with spin almost everywhere. But this one turns into a collapsing field alignment during a pole flip, which is acting like its version of spin, which is why it's like spin is involved. You're right. Like, so it's like a pole flip alignment, type thing, and then the field collapses as it's doing that, and then it creates a, hey, I'm a virtual particle pair thingy. I now exist together with, like, I'm not really entangled, I'm just going along for the ride of this guy's field. Like, I'm trapped in it. So it's like, as the photon goes and does its stuff. So, it's been described by me as like a Bernoulli's and a Venturi effect. So it goes from a larger to a smaller and accelerates and produces like a vacuum-like effect where there's lower pressure and now others want to join in. Well, when there's a lot of photons, it likes to compress it, and so the heat got managed by doing this, and then it effectively allows for that when it impacts and as a result interacts and interferes with something, it then gives it that total amount of photon information. Didn't make it jump up, photon wavelength. We didn't do any of that. It's still the same wavelength. It just now has like gained more photons per photon area. It's not, which is the reason why it's like it's compressing, and it made a bunch of these faster, like I can get in their areas for the quantum wave fluctuational function area information pressure thermodynamic stuff that goes on with frequencies and fields. It's like there's this amount and there's this area, and then it's like then I shrink the area. Oh, I can get in there. There's area for me to get in there. I'm moving. Hey. And then if you do it like that, of course, because it moved, it didn't accelerate. It just gained less resistance. All right, you can't make light travel faster. Technicality-wise, light passing through given objects slows down. Well, this is an object that it was slowed down through. And now, it's sped up. Didn't change its wavelength, though. All right, that's the caveat here. No wavelength changed, but the speed through the given lens and so on system got increased measurably. So that's the cool part, and that's why it's called the Lemke principle, phase or lens laser, which there's mirrors there too. But those mirrors are very specifically placed. Like they're, like that 3M tape. That's like a really good mirror. You know what I mean? Like you have to make the right slots, and then you have to have the right like cuts in those slots. So those are waveguides for the photon sort of thing. And then like that also has to be through the Lorentz mirror. So it's like certain areas of Lorentz lens. And then there are other like basic like plastic acrylic lens, suckers essentially, because they're two-way mirrors is what I'm basically trying to make, because behind it's a full mirror, and then this one it'll allow for some amount to go through, and then there's distance and time. There's a genuine two-way polarizational that I have to have in between. There's a Lorentz, meaning lensing system, and it gets pretty wild. But not really. I mean, it's effectively like, okay, so take like standard lens, circle. It's a little, like your eyeball, bulbous center, thinner sides. Then on sides with thinner, but actually it turns out donut effectively exist as lens. There's some slots, and then there's some holes on the inside diameter of slots around the entire thing. Now, holes allow for this uber super nice effect called reflective interference. In diffractive interference reflective parameter with a diffractive wave that is constructed to those two that I just talked about, with the one in the center. And then they collapse in front. It's a very low effect though. So it's like when you have a bunch of them, and you realize it's like it's going outwards, and then it's going to bend inwards, and there's going to be a mirror there, and the two-way mirror and the polarization. So it's like a lot of it tends to then bounce off, and then you have to allow for some of it to go through, and then it has to go around, and then combined with the ones in the front, and then the next ones in the front, and then you have to go outside to in, and a little bit from in to out. So think outside diameter area to very center, but there's a particular sequence, and then same thing from the near center, absolute center, towards middles between outsides. And you have to do that with a very specific initial setup of when they fire, and then you have to modulate the amplitude consistently, which I call it amplitude because it makes sense to think of it like an amplitude, like it's amplitude of a sound wave frequency. So it's like this is a greater degree of luminosity, so it's a very large decibel amplitude sound wave. So it's like an amplitude kind of a thing, even though others would probably call it something else, and that's most likely correct, but that's just how I do it. You know, I'd like to be corrected at one point. They're like, "This is the real word you were looking for," but we know what you were saying. Thanks, man. Oh, I'll use that word now. You know, but the reason why you have to do that specific way, and we're talking like milliseconds here that you got to work with, like, because you can't do it anything less than like that 10 millisecond range. Like that's the cutoff. Like anything below that, like you're getting better. You know what I mean? And you kind of want those nanoseconds if you can get it, but you don't really need them. You really just need like 1 to 10 milliseconds, preferably 9. You know, to make the proper firing order and also the modulation of luminosity amplitudes. Okay. Eh, the donut went around, and I don't really talk about like how specifically I set mine up, mostly because I'm like, I want to do this in real life and then show it off. And my current design, while it works, is a 2% effect. I'm looking for a 70+% higher percentage of effect of this occurring. Like I can measure it by, okay, so this is basic modulation, basic, phaser and some lensing and the proper firing order and so on. And I'm not trying to get the, actual Lemke principle going. I'm not trying to do any of that. So it's like, then I measure this given luminosity effect from a enclosed environment and then remove the air in it to detect the given values that I'm outputting for the given watts. So all told, the watts for all of this should equal this if they were all aimed and properly focused, which I can test before I do this. Then after doing this, I can then see from a basic regular phaser lens array what the benefits and detriments are to the setup time, cost, and complexity of the given design is. Then after, I can then try and make my principal effect occur, and should a 2% be there, then I expect this luminosity value to be increased by this amount. Okay? That's all that would be experimentally wise. Because it's not detecting particles, I'm detecting given informational increase, as in luminosity. So if the effect is present, there should be a higher luminosity. That's all it would be for me. Now, other people would want something else. I wouldn't care, just because I'm not going to be like a Nobel Prize winner or like anything special in my mind. So it's just like whatever. I'll just try and make it get to effect where it's like I'm getting that 70+%, because then that makes it so I can use it as a 3D printer head. I can get very small LEDs, and I can go for IR destructive and constructive interference models that allow for me during the melting and solidification phases to increase with the given output of electrical signal that it has for its controller box, as a way to more accurately define from the tip of the printer head with lowering the initial heat, but then increasing it when necessary, and then quickly cooling it in smaller areas to allow for a better 3D print over a distance further from where the nozzle tip is, allowing, of course, it's for a better defined and hard, altogether one piece 3D print. So as I melt it into the next one, and melt it into the next one, and melt it into the next one, it's just constantly doing that. You know what I mean? But then I'm able to get a finer detail and a better overall, less porosity and less of those lines and that you have to get rid of, sort of a print. That's kind of all I did it for. I mean that there are other effects that I was looking into for an IR admittance designed for cooking on a stove, or a leftover waste heat recaptured through a system in a microwave oven or something similar. So that way it would be done with less energy, but I still get the same result. More efficient, that kind of stuff. Uh, Other than that, fiber optics are okay. It's not really necessary. This is the reason why I think I no, yeah, no, I left a message, comment, not message. I left a comment on Styropyro's video about a version of this. In fact, it's basically the same thing, if I'm being honest, except I'm using a tube around a lens system that has the right grooves and slots and holes, and reflective with a around a lens that's held, that then combines into a initial final focusing lens. They had this big ginormous handheld laser they wanted to make, and I was like, well, there's a bunch of empty space here, and I don't like that. There's a lot of inefficiencies. It's good, it's very powerful, but I can easily turn this into something way better. And I used water as a cooler for the focus lens because it happens to make more light. I saw that come out in a couple of studies, and a very particular wavelength, and so on. Right? And so I was like, well, water is perfect. When it collapses, it then will increase the given amount of photon release, also being that there's like that Bernoulli's principle or Venturi principle kind of effect, where it's like, well, there's a bunch of things heading this way. Well, because there's a bunch of photons heading this way, now I'm going to destructively and constructively interfere myself into being a similar-ish, direction, and kind of in the same area ballpark of energy. But the thing is it can't really do that, and so that wavelength that it tries to remove, well, it's not good at doing it. But then what it manages, because of the other wavelengths that were collapsing in during this moment, interactively change the interference profiles such that those photon wavelengths and releases do the same Lemke principle effect over a given distance, but there's only so much distance you can get before you'll end up running into a collapse out effect. So this usually means about 1 kilometer to a few miles, depending on the given conditions. Because water, other like statically charged particles in the air, so on, end up making that effect collapse out, such that it's basically just a regular laser light. But during its collapse out, it happens to, if it's not hitting something, broad enough, it then will act as its own version of a increase, kind of like focal length. So think like this is a circular sphere, and then light from around it will slowly go to a focal point. Well, that light that reflects and interacts, so on, it basically starts doing a similar thing. And so it'll add a little bit of its energy, but it's not really doing that. It's really just trying to focus it. Like that's its main claim to fame. So like the light that's there will try and focus its light into a given wavelength and point and allow for it to travel for a little bit further with less disturbance. Which is great, but now it doesn't have the increased, total watt at the end. So it's like this was super efficient to get to this point, and I had more watts to give you. But past this, I did not. But I got it longer before I had issues, which is good. So, I figured win, win, win. But that one turned into, this is for Li-Fi. Everything's Li-Fi. Light internet stuff, like Wi-Fi. Well, it's light-fi, anyways. And the whole thing. Because then it turned into like, well, if I use radio wave signals and some microwaves that are pretty low wavelength, then it can focus through trees. It can go through a lot of organic material, kind of like what elephants will do when they have a mating call. They have a very infrasonic sound that will go very long distance. And so light waves that usually travel very long distances through objects often have a scattering and diffusal issue. Well, this ends up acting like I'll sacrifice the microwave for a continual carry of the radio wave and a refocusing of that radio wave signal through it. And there's another version of the same type of dish, essentially. Just plop it down, point it that way. Works if you get it done right, sort of thing. But it's always this give and take. You know what I mean? Like the give and take becomes really, really rough very quickly with light. It's not like sound pressure waves. Sound pressure waves are so much easier because it's like, well, then it's a given fluid, quotation marks, super quotation marks on that one, but I just start looking at it like it after a while. But it's like, this solid object has this given, resonance and this geometry, tone, like a tuning fork, and so on. And so when you get it done, and it'll come out the other side the right way, right? But it becomes annoying because humidity, different woods, different brushes, different, it just goes on and on. And so that one was like, oh yeah, no, I'm just gonna use light. It's slower too. Yeah, it's so much slower. It's way too slow for what we were using it for. Which was not just information, it was also energy transfer. So like if you get a good enough area between two different points, like those tuning forks, you can then interactively add in increased thermal, and then it can dump off its thermal as a pressure wave that will get received at just the right time on the other end, and then you get a thermal pump way further distance with nothing of a thing in between other than our atmosphere, so long as you properly focus it in a given center that has a bunch of area around that's measuring with the received resonance from that dish area effectively as a wind go this way, humidity suddenly entered, light change this, so on. Well, that little center then allows for you to transfer more of that given energy more efficiently, kinetically speaking, to the other side. Because then the rest of it's just a bunch of like contain and control and sense and understand what changed in the given area that is in between them. That's one of the reasons why phasor array sound antenna sort of things are so cool to me, but they're almost never used. So like what I just described is like a really trick setup. To put it in perspective, like a James Webb telescope, like a little thermal pump that they have, like the acoustic pump that they have, is very trick. All right, like, and it has a very specific area, very specific pressure, all the specific, like super specific, very manhandled control of the environment. You know what I mean? So it makes it much easier for them to do it. Not much in terms of efficiency if you are willing to sacrifice a given area of chaos and distortion for a more controlled, centraled area of less, which is using the basic Heisenberg's uncertainty principles to the advantage of this physics trick. So it's like a bunch of little, sound waves, and then it receives it over here, and it's trying to focus it into being a point where it's like mostly only traveling this area that it has, like the easiest, best path, least resistant kind of stuff, right? But then that's a big dish for this. Let's say it was 3 feet. Okay, 3 feet wide diameter of a circle. I can get you maybe 6 to 8 inches. You can actually use that area to transfer any kinetic or thermal energy. So it's like it's diminishing and exponential increase size problems. All right, so like a foot and a half will give you a 3 inch, and then it's 3 feet. You know what I mean? But then it turns into like actually gets way worse once you get past that 3 feet. Because by 6 feet, you really only have about, if you do it as one big chunk, because there's a couple of ways to make multiple different smaller size chunks that you can use and then ultimately get more effect and a greater transfer, because there's a larger surface area outright that you can use as bandwidth instead. But if you use one chunk, which will give you a lot of constant throughput, you'll end up having a continuous area of only about 10 inches. So 6 feet suddenly became only 10 inches. You know what I mean? And so like a foot and a half gets you 3, and then you think, well, 3 feet, 6, maybe you can get 8. You know what I mean? You do it really well. But like 6 feet, 10 inch is what you get. And then beyond that gets worse and worse. By like 20 feet, you're not doing anything more than a foot. Like it rapidly, exponentially gets just stupid. Now, the reason why I would say anything about it isn't because it's about the size, it's about how much you can now suddenly do. And because of that controllable area, how precisely you can do it. That's really all that turns into. Instead of trying to get it larger, you just try and like push more through that given area, you know, sort of thing. Now, the other problem was that when you decide to do like little smaller areas, you have to learn how to pulse them correctly and have them collapse properly. And they have to bounce between each other, that same sort of effect, like an AC sine wave, positive and negative. It's like, this is a super good DC, sort of like acoustic, and then it turns into, this is now a AC acoustic. And then there's the phasor laser, but I can't use that because I'm already using that. So it turns into like, oh, I have to then make an entirely different pump system. So I was like, this is just like, these are just acoustic waves, and we're trying to, you know what I mean? There's just like two, surfaces that are hard and a ball bearing that's super hard. You're trying to move them just right and keep the ball bearing going. Well, the DC-AC, like that, like resonant frequency that I've talked about for how it is I modulate our incoming sine wave signals as a flow current instead of a direct or a alternating, and I turn it into a flow current. All right, so this one's an entirely different freaking ridiculous, and I don't even want to talk too like deep into it because like right now it's only good for about a few feet. For like my absolute greatest pinnacle, I get about maybe 2 feet. 2 feet of distance, and that's it. This is what you get, which is just, yeah. You know what I mean? It's like I thought there was going to be long range. Well, for what it's worth, the kinetic transfer of any given energy here is ridiculous. So that like little 2 feet, I pushed what is the equivalent of a jet engine, all like um, of them on an Airbus 777, or I'm sorry, A32, not the Boeing's. Sorry, this is Airbus A32. All of those jet engines from full, complete running already, then topped up the engines, fuel tanks, and then let it run until it was completely empty on full throttle. All of that thermal kinetic in that 2 feet can be transferred in literally less than a minute. And so for me, it goes to, well, the application was there for what I was using it for, but I doubt anyone would ever really need it. But getting off into the flow current style, which will turn this, acoustic sort of setup into we're going to make it into a pump. So like there are air holes from outside and throughout the center, instead of before it just being a solid kind of thing as a plate. Now it's a one-way valve setup that blows air and then concentrates it and then gets captured and then produces what is effectively this really static, very controlled acoustically, like acoustic tweezers sort of air area, because it'll also do it on the other side. And then once it does this, they mix and then they flow in almost like an AC to DC. So it's like collapsing wave functions, and then they traveled over, and then collapse and then over. But you can't do that because I have to have it curve and then slip through in areas in which there are, at the C moment as it's traveling, no vacuum, and then once it gets there, there's a massive vacuum. Kind of set up alongside of a bunch of high frequencies and low frequency collapsing into high frequency, which doesn't really usually work very well. So I had to figure out a very weird style of using a intermediate outbound pressure wave that rides forward in between the two, that then collapses forward into a longer pressure that then is still attached to this higher pressure, higher frequency wave. So it's like it's a lower, but it starts high, it goes to lower, but then goes from high to a lower frequency, and then there's a high frequency it's attached to that then happens to collapse and then give it a lot more energy over distance for the, effectively we're creating an air tube that we're going to heavily control the environment of, which is the reason why I did it. But it also makes a outward bound pump to make that occur, like an outward bound that then also has this inward bound that has to also travel with the inward directional variances of acoustics frequencies going on, because there's always variances. So they have to be dynamic in that they are able to have a degree of distortion still produce the effect that I'm looking for, which is a bunch of fancy speak for the pressure wave go burst slightly wrong, but it's still good enough. Anyways, that one turned into a multiple collapsing frequencies over distance, like that high pressure connected to like a low or low frequency, but well, high frequency, low. Anyways, you get that like the outside area. Like another version of this, but this one turned into we need lower frequencies that are very forceful, that have a bunch of mid and high frequencies stuck in the mid that ride together with the low. So think like a baseline solid DC that has a bunch of sine waves around it that are phased, that then had a even faster sine wave traveling upwards, kind of like it suddenly turned into a gamma wave with the sine wave that was there with the phasor arrays or phasor sine waves. So it's like those phasor sine waves are that given frequency, but they're very close, and with the right interference, the gamma wave and the baseline suddenly collapses and it produces a very specific wave. But we need to remember that we're not on a flat two-dimensional plane, and so you have to remember the three-dimensional curve, and we have to remember the side-to-side and the diagonals. And as they collapse, instead of like with light, where it simply doesn't have light there, sort of stuff, this suddenly doesn't have pressure because there's less air there, which drags things in. And so once you do it into this weird little thing, which isn't so weird anymore, it suddenly makes a tube within a tube with a bunch of tubes within tubes. Cool stuff, right? But like, what does a bunch of tubes doing with inside of tubes mean? Best question to ask. That's why I really like that question and asked it, because it's like they don't do anything. This is the setup. I know, right? Like this is a whole bunch of we're gonna set it up to then finally put energy in, because we have to have energy. We just controlled an environment to make a really cool like little tube of moving air that's pretty impressively controlled, but what is it? It doesn't do anything, right? And it's not going to. Okay, so like there's got to be an outside and inside that allows for that air that's going inwards to also get captured at the inward port, and then it'll try and wrap it as much as it can. Once it gets there, it then has a benefit finally of a sealed system over a much greater distance that's far more controlled. Now, mine was in a field with a little wind, if I'm honest. So that's all that was. And it's some humidity, it's not much. So take it for what it's worth. And I never really wanted or bothered to try and use like this through woods. Mostly just because it just didn't make much sense. You know what I mean? So this one turns into, remember the whole bouncing? To do like AC or DC, that kind of thing, where it's got like a nice little receive catch for the DC, or it bounces, but then it doesn't matter. This turns into these pulses of acoustic frequencies are basically going to be introduced into the given tubes that are here, that are moving in a flowed manner in between and collapsing, and effectively have created a massive resonance effect between the two. So they're almost as quickly connected as can be with sound. All right, very controlled, very quickly. You do this, this will receive it. But when you time it, and once you allow for the proper waving of, like, let's say it was a tube, just a small tube, and you undulated the outside diameter to the inside diameter the correct way, all of a sudden you get an internal wave that's going along for the ride. When you do that properly, again, this is another setup process. It typically happens in a couple of microseconds to a couple of hundredths at most. It'll then resonate again like an AC with a DC. As the connection occurs, then a rapid increase of DC is allowed and able to be pushed. Meaning one direction can push a lot and sustain it, like massively. Uh, Kinetic-wise, I can turn the equivalent of a small little, squeeze and slight push down as it does this, because in this instance it's kind of like gears rotating at that point, as they'll go to a tube, and then when the gears rotate inwards, they'll push in, and then they'll also push out. And depending on how you set it up, it'll travel differently, and there's different ways of squeeze as you go squeeze to maximum, and so on. Anyways, it means it's now even more tightly controlled in terms of like the movement here for the flow control of the air, and then that resultant impact has lessened its loss tremendously. Like there's almost no loss, about 90 to 99%, depending on how well you do it. So, how quickly I do this isn't what it's about. It's about adding heat and how quickly I alter and change that heat and transfer. Okay, so if I'm going to squeeze this fast, but I suddenly added heat, it's like I squeeze even faster. And so if I do it properly, I get a 90 to 99% receiving of that heat value that I inputted. Which is great. It's really, really a good, efficient way of transferring kinetic to thermal, depending on how we decide to go with it. Because I can even use kinetic, so if somebody were to punch something, I can transfer that as a diaphragmic pressure wave into the system, and then have them receive it 90 to 99% on the other side. Which is cool, but it was almost like just useless in a lot of ways. And like I used it primarily as a way to just give people heat from a given source, like a campfire. And then I had like a little, just stick this here, it sucks it up, and once the setup has happened, it takes like a couple of minutes at most, and then it's like, well, now that's hot. You know what I mean? Like that's all it was for. Uh, but I suppose it can be used for like information sharing, internet stuff. I just stopped doing it because it's like it's ridiculously annoying to have anyone move at all. It is just the worst. Like, don't move. Stop moving. Please don't move. Are you moving? So, a lot of that happened, and then the other side turned into like, I can just do this with light. Yeah, I mean, like, I can just do this with light. It's way easier to do this with light versus sound wave. But sound wave made sense for, giving someone heat over distance without having to convert heat into electricity with a like 50 sometimes percent loss to more, you know, and then there's the loss of the 10 plus percent on the way there, and then the conversion from this is only like 90 to 99% from this electricity to this given heat system, electrically resistive in this instance. And so it's like there's like effectively almost nothing that I got out of that. This is a way better way to do this. I would never do that. That's a dumb way to do that. Why would I do that? I have like direct connection effectively from this heat source to that place that needs heat. They're like, we want the electricity. I'm like, you're right, but I don't like converting things. Converting always has a massive problem of large loss. It sucks. So now instead, I'm going to make a lot of waste heat my bitch. It's literally what that turned into. I'm not even kidding. It was like, so sun go burr. Well, it makes some electricity while it does it, but like this heat here, burr. Focus and concentrate. Go warm. And so they do. Is it's like, well, this solar farm is effectively bupkis. The only way this works is if it was near the 90 to 99% efficiency, and it's not. It's nowhere near that. So it's still good though. Like for what it's worth, it works, and it's far less environmentally damaging than other things. But I just it just didn't make sense after a while. I just couldn't do it. And it made no sense to continue allowing for a transfer technology that is not very efficient. Even if I make it super efficient with my nice little cool resonant frequency stuff that I use for my flow current for regular copper wire, it's still like, look at this loss. Look at the size of this loss. This is a lot of loss. I can't do that. I can't in good faith or conscience do that. It's just not acceptable. So back to the drawing board I went. That's all it turned into, especially since it was like, so what you up to over there, Spain? What? I'm gonna set up this. Wait, what? This is to do with the UK. UK to Spain. They're like, what are you doing? Nothing. Something that everybody that's involved knows what's going on, and you're gonna love it. It's gonna be a great surprise. They got a bunch of heat. They got a bunch of cold. Everybody's happy. Because you don't think it works in the reverse, there's absolutely a reverse. It's like suck in and transfer the energy into this, thermally capturing device, in which case it's just a Stirling effect, more or less. Yeah. Phase change, Stirling pulse tube, stuff like this. Simple, what I mean? But it works. And so it's like, you're cold over there. Well, guess what? You're getting heat, motherfucker! What? Where's all my freaking warm going? Nowhere. Because it's effectively a big radiator of a bunch of these little things into one area, and then like that dramatically drops heat. But it's like it's colder over here, and so if I allow for that to suddenly become connected, then it just transfers what's around to then this. It's like I'm not pushing cold. I'm removing heat to where heat is wanted. That's all that is. That's nice. It's fairly effective. But then it turned into like radio waves and microwaves will work just fucking fine for almost anything. Like you can go pretty deep into a mountain before you'll have to fucking like do something with a signal hopper, yeah. Which turned into da 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 da. This is my version of I'm an ISP, Internet Service Provider. I plugged in the radio wave and microwave jet. Okay, with a tube. Here's some tubes. Nice reflecting. This is a nice little basic bitch concrete that I made from some bullshit that was just left around. It's like, what is that? Waste? I'm gonna take that. What is that? Fecal matter? Mine. What is that? Coffee grounds? Me. What you got over there? Mine. Like, we'll happily pay you for that. Oh, yeah, thanks, dude. Appreciate it. Seriously, it's great. Made a bunch of freaking really strong concrete. Made no sense after a while for some people. It's like, how the hell are you making this? I was like, so, like, I make a really hot basin underneath, and then I make a funnel, then pump in light from around the outside into this area where it's clear, but there's some mirrors and Lindsay thingies that concentrate it because heat go into the stuff I put in, it keeps cool. But not just fecal matter. I have effectively a bunch of plastic and organic waste material and some binders, more or less. It's like, what is concrete anyways? See here, micro, nano, combiner, chemical compound, different puzzle piece to help with strength and frictional componentry. This is torsional tension stuff for chemical and other material inside. How would I do this better? What are you, waste? Give me that. This is plastic, there's some rubber, some organic shit. Works out, basically. You know, it's like, what is that? The fashion industry? Yoink! My long fibrous strands are gonna do so much work for me. Next thing you know, it's like, oh yeah, no, I have a very strong, insanely hard, but still somewhat able to handle some good flex. Concrete, yeah, it's not porous and hates. It's effectively lipid and hydrophobic. It's not static phobic or whatever electrophobic it is, like as an insulator, but like it doesn't need to be. It just needs to keep everything else out for what it's worth. Because then it's like, this is a bunch of e-waste, this is a bunch of plastic, this is a bunch of garbage, and this is a bunch of fecal matter. And here's a bunch of like cotton and plastics from the, huge waste manufacturer that is the fashion industry. Fast fashion. So it's like, these 5 parts combined form of super ridiculously stupid strong concrete. It was pretty fun though for a long while to make it, because it's like, at first I just used fecal matter and some like old concrete, so I'd take the concrete from another building and then I'd use fecal matter and a little bit of plastic waste and e-waste, and then while it would go through I'd use argon, so like argon's in the bottom, and then we'd pump it through after it had been heated. And so it's like really low pressure here, but very high pressure. But then it's like, as it goes through, it's non-reactive, but it heats it up significantly. But then, because we have a bunch of organic material that happens to break down into a lot of carbon, and then enzymatic and binder protein style material, along with the old calcium driven sort of styles and silicon dioxide styles of concrete, and then steel is elsewhere. Sorry, I'll get to the steel and so on later, but like, fecal matter has fat. Fat's great with the organic material to be broken down into and then turned into a version with the calcium and some of the other phosphorus. There's a carbon, of course. There's a few different components, because we have e-waste and plastics, and so it turned into like silicon, and then there's ethylene kind of componentry that will then collapse into becoming, well, not collapse, but they'll rip one thing off and it'll suddenly combine with something else, which I like to think of it like if this got ripped off, but then it kind of tried to, bend in it on itself, like in like a spring. It was like, torsion and tension like this, and then it's, but then it's like this is right next to it, so it just sticks to it. But anyways, sort of same thing with like the light. So like the light that we're using is mostly like an IR and ultraviolet sort of microwave combo. So that we don't want a lot of natural light. And nitrogen, yes, I get there's a lot of nitrogen. Actually, nitrogen in this case was sort of just fine for what it was worth. Like basically every gaseous component turned into a hardened to then combine right next to it or around it, very springy and like multi multi. So it's like this is a like a weird word. So it's like it's a multi poly repeating compound. So yeah, so it's a multiple compound that has poly, so like poly, so multiple compounds within the compound that repeat like a small little tiny level, chemically. And then that makes its own version of like I have a small little tiny little puzzle piece, and then a bunch of other things showed up, and then it's like, well, this is us as this bigger puzzle piece now. You see what I'm saying? And then like eventually got to big. This is the thing that we're gonna dump into that, and then once we activate it, which turned into. So we're just gonna leave it there, and then we're gonna let it be warm, and then we're gonna get rid of the water that's in there. And while we do that, I suppose we'll just let some shocky stuff go through, which essentially means we're going to drive a current, use it as a resistor in a lot of ways. So it's like, we need to remove electricity. Well, I'm going to pretend that that's what we're doing. By making a current flow that acts with transformer blah blah. It's essentially just a bunch of bullshit that says, I'm a resonant frequency that tries to push electrons out of their orbit and then remove them. It's literally all that is, but it's just like whatever. So make a field that's around it, then as it's warm, and we'll slowly allow for it to, get rid of the water and dry. And then as electricity kind of passes through, it starts to allow for a alignment, electro-ionic to covalent bond alignment profile of the pieces inside as it uses gravity to help. Yeah. So that seems cool though. It's pretty good. Yeah, no, it's not bad. The only issue was that it had a fatal flaw in that I always had to have an exoskeleton around it. It was non-reactive to like practically everything, but it's not really strong enough, like rigid wise. It flexes. It's very strong tension and all that, but like it's not very strong rigid. So we end up using like a different version. That's where the steel came in with like, well, is that silicone? Is some plastic? Some freaking okay, man. You got oh, hey, thanks. You guys got exactly what I'm looking for. They needed it gone anyways. There's some ceramic-ish kind of stuff. It was like, hey, this is a bunch of waste and we can't use it. Thanks. And it just turns into like, all right, so basically it's another version of we shock it. So it's like, can't make it hot, first and foremost. So we have to grind everything. Then we have to shock it with another version of a binder. In this instance, it's like, look, what is that? A bunch of shit that we filter out of our water? That's good. Give me that. Yeah. There's like rolled up tires, rubber, organic, all this other stuff. And so it turned into like if we grind it down, we shock it the right way, it then gets really hot while we're doing it, and then it all just sticks. But we have it in a vacuum, just an FYI there. But because of the carbon that's there, it means the carbon that's on the inside one, it bonds while we're doing that. And so like that exoskeleton is now really just a full part of the whole piece. And it's like a bunch of free stuff to like literally you're paying me to take this. So like works out. Then it turned into, well, there's an easier way to do this. This is a fairly involved process and it takes a decent amount of energy. Yeah. So what is that? What you got over there? Do I even need that? We just do this differently. Turned into so steam together with this into a mode that it vibrates properly and then quickly squeeze as it forms a pod area that can have air and steam go through. And then just shine lasers at it. Or like pulse electricity the right way. This'll work. This'll work. This is fine. I just need a field around it. Kind of. I mean, I could use the air as the field. Let me see. It's a waste. I'm going to use it for the laser anyways. I mean, the field is effectively extra electricity I need. So, zip. And now I have a tube. It was like super easy to make the tube. Any like building block pieces practically, period. Are you kidding? This is like pour it in, and this is a mold, and it was done. It's like that right there, already good to go. Doesn't need to cure, doesn't need to do anything. It's good. Not even hot, and it's great. Cause like once that's like done, then you can just move on to the next section. So it's like fast construction work just started happening. Especially when it was just, oh, so I have to put this in the ground? How deep? Honestly, not really deep. And you put it above the damn ground, it would work. But like they're not accepting that. Okay. So there's that. So this one turned into plan and boom, 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 and now I have like signal hoppers. It's like this is radio wave, then it goes to this, which is just this one area that then just gives it the extra juice. So this is like doom, whoosh, big old wide. It's like it's a tube, and it is, for what it's worth. It's like a tube, but it looks like a little bit more like a ball. Yeah, no, well, those are there too. Yeah, I can't say they're not. And then we're gonna use these. Oh yeah, no, in other places. Oh yes, no, for sure. That's all we're doing, because that's so much easier than having to do a multiple Wi-Fi signal hopper underground. But like our first foray was like, we're gonna do this. You are kind of mean. I'm really happy you're funding this and going ahead, but still, like, I have almost no ability to move any, like, there's no space here. I can't do this, I can't do, okay. Turned into that. That's why the pause was real, like, obvious. It was literally like, okay, well, we're gonna do this then instead. And so it's like a multitude of different tubes for the links that I can actually make, which then give us multiple different antenna which gives us multiple phasors and gives us all the rest of that. So, and then it turned into like we have directionality, but then we also have width, like 360. But then we also have like the pointy, pokey style of like an antenna. So it's like think 360 ball that then got squished in certain areas and then it lengthened over there, that kind of thing. But then it's like during that little lengthen area, I was able to push like a given, type of thing for the signal or just added strength and connection to where it was like, oh yeah, no, it's way smaller because it collapses, makes it much better, and then it gets to the point where it's like I don't even actually need my flow control thing, but we're always gonna have that, so we're just gonna brute force huge amounts of signal and strength for very, 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 very low amounts of actual watt used. So that's what I ended up doing for like that given city. Then rural became way easier. It was just so much easier. It was the equivalent of here's a balloon. See that over there? Yeah. That's what makes that balloon work. You have like a couple of 100 terabytes, not bits, bytes a second. Up to, as they like to say, because I can't perfectly control it, so. Still. This is for information. Yeah, no, everything was information. There was nothing about, like, energy. Okay, so we're not sending electrons. We're not sending waves that will collapse and will give you electricity distance-wise. None of that. It's, well, kind of it is a little bit, but, we're amplifying its given signal over a given distance anyways. So it's like, it'll interact and blah, 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 and then certain electrons, and then we go, hey, these electrons are near, so then just boost that amplifying part, and then be the same signal but more strongerfied, so that way I see it. Otherwise known as radio waves. You know what I mean? So that one was what I was using for basically all of the rural kind of area Wi-Fi stuff, I guess. I mean, it's not really Wi-Fi. See, like it's an internet, but then to get around certain FCC restriction problems I was like, you and I were both just talking to each other. We're just friends, we're friendly radio show hosts. Okay, so like you're gonna register this, you're gonna give it to them. You're gonna register as this given host that puts out this signal, and you only wish, so on, receive this stuff, and then we just talk a lot. And it doesn't need to be about anything, and nobody really knows. It's encrypted and all the rest, and it's really just us, talking to each other. And it turned in it from, oh, I have so many more taxes and all this other, price and so on that I have to deal with, to nope. Literally, nope. It's not even a joke. After a point, it was just so intense. You know what I mean? It was like, yeah, no, we are just radio people that enjoy talking to each other. And we have a lot of people that listen to us consistently. Okay? And of course, as that down the line get converted to what other people use in terms of their routing of network traffic, IP, in terms of internet stuff, bits and binary things. So that's when it turned into like, well, I also have my own server over here. And then Netflix and others joined in. It's like, I'll just put this here. You know what I mean? Like this will go on top and this will go underneath, that kind of thing. Next thing, for them it was like, well, yeah, no, don't even have to pay the guy. Nope. Well, you know, yeah, not really. Yeah, we're just those kinds of people. You know what I mean? Friends. There's that. Yeah, yeah. We all have to share network traffic and given amounts of data and computer. You know, so it's like we're one big server cloud network, and so like that's kind of how that works. Either you pay or you just share overall use. You know what I mean? Like with others. So you store a small amount of information that calls back to other people elsewhere that has the main information. So, like, think about it this way: the information you are storing is simply just a key to other information that will be sent to someone that's close by asking for that information. So, this person over here wants this. They say, "Hey, this is what I want," and then you go, "I have this," and then it combines. You know, you get the key first because you're closer, and that's further away. And if it's multiple different, computers, then it goes, well, there's a bunch of these redundancies. And so this is the setup of these people, in a line that will, in order, sequentially, give me this data. And they will have this key already to go, oh, so this is what this is for, and these are the things that it means. Okay? So nobody really actually has any real data, but y'all kind of do. You know what I mean? And you can't see the keys. They're not just like encrypted. It's like they're technically not there. Is a better way to put it. Yeah, because it's like they're not really stored. They are literally never there. So there's an instruction set, sure, but that instruction set is always changing constantly. That's the program that you have. So like that instruction set is tied together and synchronized with the given distances and cutoffs and everything for timing, and then says, oh, this all together is for this. And it's never not what it is, but until it's needed, you can never know what it is. But that takes like calculations, right? Only if you're opening that. What? Right, yeah, I know. So like the program is such that it's only there when it is being used. And a way to showcase what that would mean is, since you're going to do anything online anyways, you will be sending and receiving packets constantly. As a result of receiving packets, it changed this, but you got your information just fine. And then as you're sending packets, it changed this, and it now also happens to be sending that to everywhere else that's the change. And since they're always synchronizing, and there's multiple redundancies, not any given calculation is wasted to do this. Because you are already going to get this, you're already going to perform that calculation, it just happened to output for this already given thing as well. Beyond that, it turned pretty quick into like So, how much do you feel as though you want to have a shortwave radio signal be a part of our network? And so the entire world was pretty quick to jump on that one. It's like, we are the biggest radio station to ever have existed. You're not a radio station. I'm definitely a radio station, and so is all the rest of us. And we fought hard, and we won too. No one really fucking fought or challenged us much on that. It's like, realistically, it doesn't matter. They are listening. That's all it is. It's just that. And so they couldn't really call us on that, and then that was our given frequency stuff, right? And so it's like, we're allowed that. That's our channel. Me. We bought a couple of channels. They, all work within the given channels that they're able to, receive and send. And so it works out pretty well. How do you manage that when it comes down to like multiple people? Oh, right. Yeah, no. So radio is a cool one. Okay, so if you take, like, for instance, your router, your router modem that you have at home, and multiple people are using the phone. You know, everybody's using their phone. Like, multiple people are using a phone in their home. Okay? Yeah. Well, all of that traffic has to go through the modem and router combo. So it's like multiple people can be on the one frequency, but so long as it's spaced, like phased, and properly identified, it all works out. There's no crosstalk. Yeah, no, so yes. We That's the setup, because all we are is not just a radio station, but a wonderful company that helps people become amazing radio hosts. And just provides them everything they need to do it. That kind of thing. It's all I do. It's all the company did. You pay me, to like kind of help you maintain your following and your ability to send out that great signal, and all the good stuff you talk about, or you share with others, and that makes it so that way everybody gets everything done much easier, and you still get all the same great signal, because everybody's able to make that a lot easier to happen. Since I don't have to take care of everything to make that happen. In fact, a lot of people are making every effort to take care of all of the parts that they need to, so it all happens that way. And I'm sure there'd be a decent few amounts of laughing or snickering or giggling, but that's what we are. That's what you are. And for us to receive things, of course, we want to make sure it's safe, secure, and same thing with you, and no one else can get it. You know what I mean? And that's another reason why it's a very specific, um, you know, stuff setup of stuff that we give you. Okay, for a receiver and antenna and dish and so on. Yeah. Thanks. Do you use Li-Fi? I still try to. It's a hard one because like this is Li-Fi though in a lot of ways, you know. because radio wave is still a electromagnetic radiation light. It's light, so it's just being done in a slightly different way. Then we have the other caveat, which so depending on what people wanted to do for their given situation, they had the option. All of it is there. It's just what they choose to set it up as. So it was like, well, you can use the acoustic if you want to, which is like an infra and ultrasonic variation there within. All right, and so it would map out where you set it up, the whole area that it's kind of like enclosed in or able to receive signal back from that reflection to pass through and so on. And then it turned into, you know, this little dongle that would be, or something similar, that would give you your Wi-Fi. You know, it was really high bandwidth, but past a certain distance, you wouldn't really want to use it much at all. And there's always a degree of pressure, just constantly, even if it was pretty cool that it was also an active noise canceling device. Like the equivalent of like I ripped down my drywall and I put in the soundproofing. You know what I mean? It was that level of cool. It was like I could step out here and be loud as hell inside. You wouldn't be able to hear anything going on. Well, kind of, you know, like yeah, I know. Yeah, it's people really wanted to test that one for a long time. And screaming, oh yeah, no, it's fine. But like they ended up getting bikes and just revving as hard as they could inside their helms. And it was like, well, you know, past that like 25 feet, I can't hear it. So, well, barely at all if I could. Yeah. Meanwhile, I'm like, please don't do that. Still, because of the way it reflected, because of the way the dongle works, it makes it such that it can now track you. Then it turned into the light, you know, Li-Fi style, you know, kind of like Wi-Fi, but like just, you know, the dongle also has light, so it would combine the two because it already needed to set up this stuff anyways. And there are already also Wi-Fi hotspot hopper things. So it was like, yeah, just put them together. You know, this is really simple. It seems like, you know, yeah, doesn't seem too hard. It doesn't need the acoustic. It doesn't need the Wi-Fi, and maybe it can be, and you know, like, and you can set it to be specific this, or most of the time this, and then switch only, and stuff like that. So it's really all it really turned into for that kind of a thing, because that was a simple, easy way to do it. Because in order for me to move the diaphragm, I needed a resistor anyways. A resistor of lights makes total sense, and then the way it moves the diaphragm is essentially the equivalent of a coil that makes the Wi-Fi signal. Real efficient. Yeah, I try to be. Most people didn't want to do it, and they just hooked it up to the Ethernet. It's pretty fast, you know. It was like, yeah, that's neat. Dunk. You do all this stuff, but then it's just like, yeah, Ethernet, and it works. So I don't care. Honestly, to each their own. It's all good. I never really minded at all, and do what you want to do, kind of stuff. So that's really all it turned into. For like if they were worried or whatever, like if they needed to have the Ethernet or if they had to have this or that. It's like no, you can do whatever. It's got all of it. It even has fiber optic if you happen to have a fiber optic in your situation to even light to light, because like those light receivers, that dongle is essentially what that is like a wireless light. So it would send light directly to dongle or hop it along the way. And sometimes that would be more than good enough. You know, I mean, I have a couple hundred terabytes a second, and then it's just like, oh yeah, no, I'll be 150. You know, I don't even need my property anymore. Just stick this on here. I'm still receiving. They're at their wherever it is after a certain point, because it turned into, how high can I have that balloon? Oh, there isn't really, technically speaking, a limit, except for what the FIA or whatever it is requires. So that's their thing. I just set it up like, well, this is for sure good to go. And you can rise and lower it up pretty much a little lower, about 3 meters, but you're going to start losing signal. And you can go higher, pretty darn high, and you won't have a problem, if I'm being honest. So there's that. And that was pretty much the end of that, because there wasn't much else to do on it. It was like, well, here you go, Africa and India and pretty much everywhere around the world, because it was that fast. It's just like, oh, you have a satellite, right? Yeah. How much do you cost? A lot more than you think. Hmm. So this is a blimp that stays out here in the Atlantic and Pacific Ocean. And some of these are around here, and it was done. It was that fast. I was like, you are that excited? I can fucking cover like the entirety of the globe with that amount of fucking money. Just gonna use signal hoppers again. Screw this shit. Turning very quickly into like, helium is expensive, isn't it? No, we're not gonna use helium. Screw that shit. Helium is stupid. What? Oh yeah, no, helium is dumb. I don't like helium. You're gonna use hydrogen? No, I can't use hydrogen. You cannot use particles. I'm allowed to do whatever I want. No one says I can't use protons. No one says that I cannot use protons. What is this anymore? I got a cease and desist letter after certain increased activity in Google searches for my company happened. It was a rough one for a while, because I was like, how do I make a quark? Oh, I'm not allowed to use that? Oh, they don't know how to make these things. Thanks. Just gonna figure this out real quick. How do I make these fuckers not do that? Well, I have like a static thingy from like the thing with the sun. Nah, it's not gonna work. I'll just use a boundary. A boundary would fucking suck. They suck at touch. It's true. Hmm. Nah, I can't use nuclear. Chromo likes to collapse into electro. What? Yeah, whole thing it's a problem. Can I use light pressure like they do in the sun, in stars? Maybe, I don't know. That's a possibility. Okay, let me look at that. Just gonna have it constantly collapse into being a bunch of little tiny quarks. What? That'll combine briefly and then they'll fade and particle duality pair. Virtual Hawking radiation bullshit. And then I effectively created what is the equivalent of a vacuum virtual particle briefly existing proton pairing quark creating photon resonance chamber for all of my, with just some solar panels and a little bit of windmills for electricity and stuff. Blimp and helium is lame. I use so little. I literally use nothing, just electricity sometimes. And it worked very well for what it was worth. That one took a little bit of time to do, but it wasn't that long. And I had no radiation exposure at all. In fact, I actually absorb radiation constantly. Problem is, it's like, why is there a neutron in here? Ah, fuck. Where'd this helium come from? Really? Yeah, no, eventually got to helium after the hydrogen got in there. It's like, how the fuck did the hydrogen, where the fuck did this bastard come from? Where do these electrons keep coming in from? Where's my insulate? Oh, fucking damn it. Some bird pecked into my thing. Exposed a wire. I had a quantum tunnel effect. Started making hydrogen. It's a whole fucking shit show at that one. At that point, it was like I was just constantly making hydrogen. It's just freaking the worst. From light and some electricity. It sucked. Right, I guess I'll have to explain that. So, photons still have quarks and shit in them, right? They're not empty. You know what I mean? We don't know how it removes its Higgs boson field as like an anti-Higgs boson or a like clever conversion, I suppose, into like this Higgs into no longer being a Higgs seen in felt effect to anything other than maybe itself, sort of thing. You know, so we're all dealing with that part, you know, in the quantum physics realm of things. I'm still on the partial side of it has mass. We just can't see it because it converts the mass and tries to hide it away. That's kind of what that turns into for me. But this turned into, all right, so a bunch of protons in no way can happen, right? But it's like, no, 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 they turned a bunch of fields into an actual particle. And I was like, yeah, no, yeah, that's true. So what are the fields elicited by a bunch of fucking photons and like electrons in a given like sequence of data? Input like little act like I have a virtual bunch of photons. Yeah, I mean that's what electromagnetic radiation is. Yeah, pretty much. But I mean they're actual like particles though. Well, um, they should have protons though. Yeah, well they should. You mean quarks, not protons. Right, quarks, right, yeah. Fair. But like this is gonna be a hard one. They have to elicit a field outside of themselves. You know that, right? Like they have to do that. Yeah, well, true, but right. Why is that? Okay, why do they even have quarks? If they're just like little spiky parts of a given field that's electromagnetic that then extends because of clever like little, you know, phasing and then push, you know, collapse instead of like going wide 360, then it goes and then it goes forward like a fucking, you know, incandescent bulb that then had the proper like little things around it that then made it get focused as a coherent lens and destructive lens. Well, yeah. Okay, so but then fields, electromagnetic fields have quarks, is what you're saying. Well, not until they do that. What? And that's what is the basis of quantum physics in that area. Not even a joke. It's like, well, no, electromagnetic fields don't have quirks or whatever. And then you're like, no, they do because they're electromagnetic fields. Yeah, no, but they definitely don't have particles. No, they do. They call them these names, and it's like, but they do. But then when does it turn into suddenly now it's photon? When convert happen? When do convert happen? Thanks, Phaser. Let me know someone who's out there. They have to shed quarks too. There's no way they're not doing that. And there's got to be a directionality aspect for their conditioned, like, coalesced form. You know, like an electromagnetic field happens to be when it's stuck to this given coil, has to go back to where it was originally. And so it's like now it's just a big, like, plasma field line almost of these given little tiny particles that elicit a given effect around outside of that, and then it dissipates so significantly it might as well not be there. Well, yeah. Okay, so then what does it resonate? Is it spin? You say it's pole alignment for these things, but we know that's not really what that is. It's a conversion of the spin and the ultimate kinetic movement within its orbit, the electron, and how it transfers a given, uh, you know, perceived particle over a given distance and its area of effect and structure there within, like a big old coil cable that is just really a field that you like to use as the particle quantum physicist versus the field quantum physicist. But it has to spin. You know what I mean? Like it can't not spin. The conservation of momentum has to allow for it to come back in. And why does it convert that to that? Because it just aligned and you allowed for it to vibrate the right way? Well, yeah, pretty much. It's an effect of the fucking okay. I see what this is going to turn into. So, did you know I knew all that already and I was just leading you forward to this point? Because it feels like you just picked up on like how much I know. Anyways, virtual particle pairing is literally the equivalent of this is a thing that exists here technically. You know what I mean? Like virtual particle pairing, and I'm like, yeah, boohoo, someone else. Don't care. Suck it up. Because we've done it with other things. You're thinking quantum vacuum. We just don't have a good way of seeing them, obviously. Because while they're there in a sense, they're always going to collapse out into being the thing that they are not, making them very, very difficult to see in any direct or even indirect response. So, really, in terms of detection and censoring, you can only get them after they've done the thing from collapsing. So, knowing this, which we don't have to do much more than this, because it's like, okay, there's a bunch of quarks here that effectively are constantly spontaneously existing for a brief period of time, and then collapsing into a given constant field effect, as it will have this given conservation of momentum that will lead into the next field. That's the old electromagnetic field. So a photon then is simply something that continues to travel as a spike wave with a field around it that it's continuing to use as a supportive matrix to keep itself continuing as it will absorb other given amounts of vacuum and more fields to continue allowing for the spike wave to exist doing what it does as a resonance phase. Yeah, I suppose that's jeez. And now proton, because sacrificial for so-ons happen to happen, then make fieldy field be entangle-wangled to continual collapsy state superpositional, doesn't really have quark quotation mark, but does, and it's just virtual for these other things that we have a hard time seeing, thus making it go, hey, then I'm no longer having this so much. Because I wasn't even there even. Actually, I removed my mass too. While I did this, I made a virtual Higgs boson that collapsed out my boson field, making it seem like I don't have mass, but actually I do. Then I continued traveling by making virtual pairings that collapsed and gained me energy from the fields around me, man. As a result, it's like I'm in a big old superfluid, bruh. Able to go this constant fucking wave frequency, bruh. Then I hit something. I couldn't do it anymore. Feels bad, man. Life was cool before that point, because then it looks like I'm in absolute zero. Ooh, yeah. I have no thermal momentum. Strangely enough, there are a lot of quantum physicists that just probably like, that's really intelligent, but fuck you in a lot of ways. So, I'm going to move on to. Alright, so we're not in any way making virtuals, right? Because we can't, correct? Right? Well, see? Now, if I have a given geometric shape that happens to create given areas of influence and interaction and ultimately higher probability bell curves of given situational Feynman diagram resultive occurrences due to the interference forces going on. Bunch of big words that mean. So basically, I made certain areas that are close together and do the burr right. Meanwhile, big lingo means smart smart. Look at this fucking. I want to actually talk about this, like genuinely. I like just fucking shitting on people, but still, this one's actually fairly decently complex. I learned, I had to learn how to effectively do something that they've never done before. Period. So it's like, all right, so this is an electromagnetic field. If I happen to start it during this moment and during its start of making this occur, while this given collapsing destructive interference of these given photons in this given wavelength, which then creates a continual interactive area of this light and electromagnetic field traveling together in the same amount of speed, while also having this destructive conversion energy be made to forcefully uh, entangle, I suppose is not a good word, because it wouldn't be entangle. It would be turn that energy into making the virtual, and the quark, electromagnetic field ons that are there, because there are always a bunch of ons and in and I'm so over it. And it like turns into this given type of I'm now a thing, which makes it, instead of virtual, we get a ghost that tries to collapse towards an already faster moving proton that happens to be in a wavelength that is the same as it, thus really entangling a ghost particle, quark, to a proton. But because during the proton's destructive and blah blah, to me it turns into so a bunch of words and funny stuff that means I'm no longer really a proton, I'm more of a big old field because the quarks that I was going to originally have collapsed out into the ghost particle. And so instead of it being in front, it goes bye bye, and then behind goes hey hey, with the informational energy that was this photon to this ghost particle, no longer making it a ghost particle, we made it a quark. Quarks. I made quarks. Quarks go burr right, reflect off. They sticky, but also go bye bye. I don't like you. You're not the right one. So different wave frequencies, different strengths, different freaking positive versus negatives. You know, and there's low, DC, and AC have to be combined. This is a whole other fucking shit show. Mm-hmm. And then it goes, all right, so I'm heading towards the center. There's a big pressure. I don't really maybe want to go. No, 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 no. You don't have mass. Why don't you want to go? There's pressure. There's no pressure. What pressure? What kind of pressure do you think this is? What pressure? You don't have kinetic. You have no mass. Nothing says that there is something there to you. Remember, ghostly quark particle? Ah, field. Oh, you mother bitch. You. Ah! So there's now a pairing from this outward bound as they, go through and then bounce and so on. Right? Right. And so now, since there is this field, because travel different pole and flip alignment spin stuff, which is a bunch of stupid words to me, means it only just did this basic thing called it went from hand forward with wrist towards self to suddenly wrist away from self and hand towards you, you know. And spin went from this to, oh, while I did this, I continued doing the different spin, which now makes it so I go, no, 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 I don't want to do this spin, so I'm going to do a different spin now as I do the flippy. I'm not even kidding. That's literally what the math says, but they're like, no, it's a bunch of words and big stuff. And I'm like, it's cool. It is. It's insanely cool and impressive. But still, this went this way, and that one then suddenly doing this instead of that. It's literally what it meant. But you know what it meant, though, for this little ghostly thing? Remember the ghostly thing? It was like, I have the field. Where the field was like, oh, I was supported because you went that way. Well, guess what? I'm not there. I'm doing a different way. And it's like, well, whatever. I don't control you, so. And then this guy, I'm still doing my normal. And large amounts of pressure. Weird vacuum pressure. Yeah, no, actual vacuum pressure. It's the opposite of heat, is what I'm really trying to say. I get force, kinetic, as a vacuum, because there's no real anything there. You see, the quark never really happened. There was never really mass, because it's light. And all that combined together to go, bye-bye, I don't exist. So the relative believed not to be there mass and the relative I don't exist kinetic inertia momenta suddenly goes to, ooh, I'm a big old fucking field. Goo. Go over that way. Maybe this way. This, that, that thing. And then there's got to be a lot of them to make that work. And so then that outward bound, inertia then like also helps make the outward bound like upward lift of buoyancy. Yeah, but it's not exactly a big butt-shaped blimp. You ever see those things? They kind of look like a butt. I don't mind it. I do like a good looking butt. I'm just saying. But at the same time, this isn't what it's doing for us. You know what I mean? These are essentially a different form of convection. Okay? So it's like air can't be involved in this process. It's very much not a rigid structure. It starts off deflated, meaning very just got nothing in it. And eventually you have to like slowly fill it up doing this outward bound, and then it'll, like a hot air balloon, be big, and that's its buoyancy because it has no actual anything in it. It just has pressure from nothing pushing it outwards, making a big, I am definitely way less dense than you. And so now I floaty. Oh, buoyancy. How much electricity does that take? A fair damn good amount. But it's my resistor for like my radio wave, so I have to make the radio wave stuff and the microwave stuff and like the multiple microwave, radio wave, and there's even some IR collapsers for like the blimps that I have to have for distance because IR at higher altitude is more prevalent than at lower altitude. So there's a whole thing going on with that. So, but it basically means I have a phaser laser array around the world. Closer to the ground than anyone. Oh, what is this? A rotating weird inertia network of satellites? Nah, I'm good. I shall just plunk down this buoy and put a balloon attached to it. It will make me wave energy because I will have multiple buoys. I'll have a couple of cross. What is it? Not cross. What is that thing called again? It's the fans that rotate counter to each other. Counter rotating, counter rotating. Fans and some shrouds that are helping with the lift sort of thing that the attached cable has to be to this blimp of nothing buoyancy. In a vacuum sort of thing. That has solar panels on top of it. What do we use again for rotor wires? Big long cables, I think. Oh, that'll help me. We're gonna have a bunch of shrouds. Yeah, that'll probably help. Yeah. Basically everything works out. Ship shape. Woohoo! Look at me monitoring so much of the weather data around us in the oceans. I'm pretty cool, yeah. Do you want internet? No. But you do want people to listen to you on the radio, right? Yeah, absolutely. I got you covered. Yeah, that's just literally where it kind of ended. The only other one was like, I think we can use clouds to our advantage. What? Yeah, no, IR can reflect off of clouds. Same thing with sound. I thought IR absorbed with water. Oh yeah, that's true. Huh. Does it emit IR? What do they do at the top there with ultraviolet and IR? Do they shine light away? They do something with light, I'm sure. Anyways, it was a lot of that for a while, but then it turned into that's not exactly consistent. So we never really went there. And kites were another version of the same thing. For it was like, well, this is a mountain. What's the difference between this blimp and like a fucking kite, bro? Yeah, much anything actually. I actually don't see a difference. Yeah, I think the blimp's better. Blimp's gonna continue being able to fly. That's true. Yep. Oh, hey, look, this is my airplane. It now has a reflector and all the rest of it. Oh, you! I couldn't let it go. I was like, I shall make something work with this. I will make an outward bound constant pressure passively with the light and vacuum pressures that exist around us. I will now have buoyancy occur with ultralight, strong as fuck materials that make no sense whatsoever. And so then I made that sort of like it's like look at this clear film, and then flies away as he just fucking like holds it. He's just flying away. Yeah, I was like fucking 250, just. It's like how the fuck do you do that? Light exists, and then we make a boom boom, which is a zappy zap, and there's a kapow and a whoosh. And then I go bye bye. Yeah, they're like nanomaterials, right? It's a microfilm. I can't do anything with nano-sized stuff, unfortunately. It's just too finicky. If it ever happens to have a slight problem, then it all stops working. And so, like, micro means I can get away with a lot more before that, before a nano will. So, turned into I'm gonna layer a few nano things together that aren't really nano, they're all micro, but because I microed a bunch of nano, you mean nanoed? In no way. Stop interrupting over there. I don't know what you're doing. So I have a bunch of microfilms that then intersect below nanometer ranges, and I can have multiple layers fail before a given point where it will no longer work. I then allow for that vacuum pressure to be exerted in a given directional aspect instead of unidirectional, which was a whole other shit show. So it's a literal vacuum pressure laser. Not even a joke. That's literally what I did. I was like, look at me. I'm flying with fume. Look at this. I laid several films together, and then now this is the lightest aircraft ever to have existed to get to space that was powered by my pedaling bike. Look at this. Look at this cantaloupe. Oh yeah, look at this. These calves, don't you want to smooch? Look at these toes. Oh yeah. This is pressing him on some woman's face. I'm laughing my ass off at that one too, Yuri. But like, it is what that was basically. Is I was like, oh yeah, look at that NASA guy. He flew like pretty far on that pedal powered bike thingy. Well, I don't even want to try and pedal, and I just want to get to space. So I then made everything out of this because, like, depending on how you layer it and structure it, and then like make it, stiff to not, right? Then turned into like everything's a massive buoyancy. It is literally able to go to the very edge of space. And then all I need was the right amount of twist. It's a balloon. No, 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 no. I had to store thrust. Not even a joke. The pedal thing was literally nothing more than like I'm sucking air in and I'm storing it. And everything else turned into I am going to manage the thrust that the constant lift that I get and buoyancy I get, like the wideness, kind of like the blimp of the wings and so on. I have to sit in something so I don't die, that sort of stuff, right? So this one quickly turned into, well, I have to manage my lift and then I have air around me, so I need to thrust air at different amounts into chambers and then suck more air and thrust more and blah blah, and so then I eventually got thrusters. Within that context, as it'll just vacuum pressure thrust, but like turns out vacuum pressure ain't exactly so easy to manage. It's just sort of brute force in this direction, and it don't really care that much about interacting with itself because guess I fuck you, I suppose. It's like no, effectively just I'm tunneling to move whatever the hell that is, maybe sort of thing. It was the worst after a while to like figure out how to get interactive and interference forces to make them try and direct themselves somewhere. Not so much in the film, more so much like into anything at all that's moving, because it just goes that way, sort of thing. And that's all you got. It's like this way, and whatever's over there, that's what it's going to try and push that way. And it's all you're going to get. Basically, I got a very small amount of something by layering them. Yeah, it's a bunch of more layering. So it's like this allowed for that to go get pushed first, and then if I had nothing there, and then a little bit, and then if it traveled about and then it hit it, and then this would have already been hitting it, so then it double hits, sort of stuff. Is literally all that was. It was managing it with like sliders and some fucking knobs. Yeah, I didn't want to get into it because like it worked beautifully well, but wow, is it just a never-ending shitfest of management? It's like, what's that fucking saying over there for fucking? It should be that for this. Okay, all right. Yeah. Basically, just had to micromanage everything because it can't make electronic components work with that because they would move. Oh, yeah, I had to get it from the given airspeed coming out of those nozzles, which was difficult because, like, then it turned into I now need to make this movement be neutral somehow, but still give me a given effect. And so electromagnetic stuff happened. Yeah, it's like this is an electromagnetic field, and that stuff and changes. And we're gonna use this. Not even a joke. Not even. I also had laser stuff. Yeah, no, it was light passing through a given density and velocity of air creates a lensing. So we would use that too. And by their forces combined, we have an accuracy of 99%, measured by an even really way higher accurate calibration of something else that measures wind speed and air velocity and stuff, which was a hard one to even come by. It was like, we got to 99% of that. Did you say that's not much? That'll mean a lot at some point. For like those this particle accelerator or stuff like that. It's actually a pretty big deal. But this is pretty good. It's working. And then it was just okay, so this is for this, and we had basically like a little graph on there. It was like, at this, and check that, and then this is where you put it. That's all it turned into. But no, you actually do have to cover them. Like, you have to cover the nozzle and the intake until you can actually get going. Yeah, and there's so much weight you have to put on it. And you have to cover up the film to have it stay inside, and then basically move air out away from it. So it's like you're in a situated little lower pressure zone constantly, as it'll suck air in, but then it'll push it away. This is the worst. Well, the worst in the sense that it's like, it's kind of dangerous to go near it if you're at a particular altitude, because by that point there isn't air. It's an inactual vacuum. So that was what that was. But we all the way up to the upper atmosphere, and then it was farting out the petted power juice appropriately with the thirst. To then be able to gain the necessary, I'm in space now, suck it up, losers. Me and my team did this, and you weren't able to. Suck it, suck it, suck it, suck it, suck it. We're great. Oh yeah. And I have to come down, which that one was a shit show. Oh really? How did that work? Not easily. It's called reverse thrust, and it's dangerous. It's really, really dangerous, actually, because it goes, oh, I'm in orbit now. Look at me at the lowest orbit point that you can really reasonably have, if I really want to be honest. And now it's to go reverse dial is back into the atmosphere. Oh, God, no, 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 no. I'm traveling very quickly. You know this, right? Do you understand how dangerous this is? Yes, you're the one that wanted to do this. That's fair. Let's get it done. I was honestly content just being in orbit for a while and just never actually coming back down. Just like, no, guys, you guys. It's fucking edge, actually. It's so fast how fast you travel. Just be in orbit. And so it's like, let me just slowly slow down. I'm going to make a massive inclination type of change. So it's like, I'm going to accelerate to being really high, and then I'm going to go really, really slow because I'm going to slow down. And then it's like, I'm going to dip back in. It's effectively, I'm doing a loop-de-loop. Imagine that. It's like I'm in a circle, and then I extend one part of the circle of the orbit, and then I go up, and then there's a little down, but I didn't actually do any of that because that's a huge fucking waste, and I don't want to gain any more altitude for increased gravitational fucking acceleration. So it goes into, I'm extending it, and then now I'm just gonna drop the hell down and try and fucking reverse thrusters. And then it's like, reverse thrust, bitch! Oh yeah, that's right, I have to go into the atmosphere. Good thing I have lift from my wings. Glide away! Where do I land? This is the spot, remember? Oh yeah, no, that's so super easy to see. I definitely know where it is. I'm just gonna head that way, is what they said. So what that was, it's over there, I think. Land seems to be indicative of where that should be in terms of its formation. Hey, that was it. Yeah, right there. Yeah. Oh, fuck, that's right. Oh, fuck. I still have thrust. Used to have lift, now I have, like, lots of thrust. What am I gonna do here? Where's the buoyancy thing? Holy fuck. Uh-oh. Where's my glide? It's managing the thing, man. Oh, yeah, no, that's true. I'm just freaking out. Yeah. Right, it's right there. It's for buoyancy plus slight amount of lift. It's literally what it says. Alright. There we go. Now we're cooking. We're gonna land just normal. My fucking lord. This is the lightest thing I've ever been in. There's no continued momentum. Holy fuck. Stop with the wind, bastards! Stop! Wind's pushing me up massively. Ah! Yeah, I land. Just barely, though. I'm kind of over on the right side. Just cooked over to the left with my wheels. The whole fuselage, I'm just over there on the right side, but it's like, oh yeah. Get in, it's fine, basically. It's done. It was like, oh yeah, guys, it's so great. It's not something you'll freak out at all doing. No, this is definitely a product I'm going to sell at some point. Proceed to like sell one or two of them to the military and NASA. I'm like, well, have fun. If you break this, they effectively can't repair it very easily. It's kind of made as a one piece, sort of like multi-part construction thing. How do work thingy-majig? This very precisely worded controls here. It's exactly what it do. Oh, yes, no, ah! Oh, he must have put it to 100. Uh-oh. Uh-oh. It's a good thing it's a pressurized fuselage, so you won't have to worry about that. He's still going to be in one atmosphere by the time he's up there. Can you get him down? Oh, yeah, no, yeah, for sure. Yeah, no, just do the reverse. Oh, fucking don't do it that fast. Dude, what the fuck? No wonder why we have that failsafe. Good old altitude barometer thing. Look at him. Woo, stone falling. Fucking almost dies. Bet you fucking felt that one. But not even free falling. I got thrusted down like someone threw me as a stone to the ground. Whoosh. Ah! These guys, they make me laugh so much these days. You know? I don't know. You're the one that touched things. What did you touch? I didn't touch nothing. There are records stored in these things of what you did, just so you know. You know. But I've touched some things. It's, you know, I know. It's probably the thrust. You didn't think it would be that hardcore. Yeah, we had it as, like, where we could get to space in, like, I think a couple of minutes, maybe like 10, 12 minutes at most. And really, that's only because at the very outer reaches, we're not able to get a lot of that buoyancy. So I'm pretty sure you got near that 100% thinking that it wasn't going to be that big. Which is all good. We did the same thing. We really didn't think it'd be that big of an effect, and then we had an issue with accelerating very rapidly. So, no harm, no foul, buddy. Meanwhile, the astronaut, like military guy, just sort of wobbles. I'm not even kidding. It's a fear. It's a huge. It's like, dude, this thing will get to the edge of space that fast. Like you have like nothing you can do. And while it's not like a NASA rocket ship, but still, it's effectively nil in terms of the cost, for fuel, right? Which is the whole reason why I built it. It's literally it. It's like, oh yeah, no, if I want to make oxygen for this is a lot of actual cost, or I could make this, right? And it's like, yeah, but you need a lot of all those things to be able to make that. That's true. Yeah. Hmm. Still be cheaper for an average person to do that thing, get to space cheaper or cheaply, you know, YouTube video versus doing that thing, which would be effectively very hard one. Because this is specialized manufacturing that I made specifically to do this kind of stuff, which was a hard one to get to, anyways. But I had to make an ISP. In no way, but one hell of a company, to send people up to be great radio stars. Oh yeah. Yeah, but yeah, it was a scary one for a while because they're like, you can make this turn into anything, right? And it's like that's not really how that works. Okay, so like a given amount of light that's around us, and that changes depending on what time of day and what part of the year we're at. So as you get higher up in your atmosphere, of course, there's less buoyancy, but then you have more light. And there's a balancing that gets done, but after a certain point, you can't do the electrical uh, expansion kind of thing. You know what I mean? Like you can't do like the buoyancy part with like in regards to making an area of effect that is interacting, kind of like a big old bell end on the bottom part of the wing and fuselage kind of area. So once that occurs, it's pure and simple, like, well, there isn't anything to equal opposite reaction at all. And so this big, ginormous, this is way less versus this, you know, because it's like underneath and above has turned into this kind of balancing lift characteristic, but with a huge buoyancy, like I'm sticking this thing that's around me that then weighs effectively nothing and is thrusting away anyways as it'll gather in the lifted area into where that is and then pulls it away or pushes away really, and we get our thrust lift characteristic and buoyancy. Okay, but you can't get it around the fact that there's no air in space. Okay, which is why the pedal power is all about storing energy and keeping a degree of equal opposite. But because it's so much more efficient when you don't have something in the way, and you can thrust something with light that hard as a almost, I don't even know what that is, but really high thrust characteristic, acceleration for momenta, then it turns into what you store is great. You only need to use it almost like that ionic engine stuff, but it'll come away at like really, really high velocity. We're not at like 99% speed of light, although with the right like setup, you could probably get there, but that's not what this is. It's more like in the 30% speed of light. It's still quite fast, and so like you get a lot of thrust potential for a very low mass. Since you're willing to do the bare minimum to get to space, I figure you're willing to use the ultra efficiency that creates when you have almost no real need for anything other than sunlight. There's always gives and takes on that one though. It's not really a solar cell, you know what I mean? Like a sailboat, because it doesn't reflect it. But at the same time, it does manage to mean you can get into space and you can get into orbit and you can return back. And you can't be there very long. So effectively, you'll do one orbit after you've established an orbit and done the one orbit to make sure that you are in that orbit, and then you'll go back. Because that whole I need an A and then E and all that, that's on the return back orbit. You really don't get like a lot of like time. You really don't. It's basically this is you in a strapped tiny little area and have fun. Yeah, no, but see, the thing is, it's completely 100%. Well, not very 100%, but it's transparent. You know what I mean? So, well, in certain areas that we made absolutely certain you couldn't get burned by the sun. Wow, that fucker gets intense up there. Yeah. Turns into the standard polarization, multiple layer sort of thing, and then some reflective material. So that way I could get a little bit greater achieved results in terms of not dying in the area I sit. Still worked though. Oh yeah, no, it worked beautifully. Worked just fine. That wasn't the issue. Most people literally stated constantly that we never did it, even though NASA and the fucking military both came around and were like, we did it too, and they definitely did as well. They were still like, no, I don't believe you. I was so fucking pissed. Everyone really was after a while. It's like, fuck you. Really? Why? So how does it work again? You make a particle destructive carrying with protons, right? Yeah. Yeah, but then it's given inertial acceleration radiates outwards in the 360, utilizing the basic principles of phase and alignment of timing for phase shifting and all that. You end up gaining a panel of an improperly layered and appropriately made that happens to use that 360 effect to interact with itself, kind of, in such a manner that it makes it one-ish directional. That will, once it makes a directionality occur, then rebounds that ish part back to where it was already going to have more coming in, and then changes that coming in to having a different direction, an interactive interference constructive destructive profile that makes it then go back towards the direction and then oscillates there within. So everything travels the one direction. So it's like this one goes that way. Then the other side that I couldn't get, I then made go that way. And then that side that I couldn't get, I made go the same way. And then I did it again, and I never stopped doing it. And so that was like the basic of that. And then you already heard about how I, manipulate distances in terms of where it's going to be doing this. So that way it's majority wise the direction I would like it to be going for increased efficiencies. Now, buoyancy thing is like, well, buoyancy doesn't work like that. Like boundary layer and surface area contact to the given area that it is trying to interact with can be extended because of this force that we're making, which is a quantum vacuum force, which is really just a more kinetic force. Yeah, it's more of a unidirectional kinetic force. But it uses light. Light can't do force. Proceeds to look at all these very bright lights that say that they can absolutely force things to move. Does that heat it up? Is that moving? Ah, no, it's not. You're a quantum physicist! Revoke your PhD to me now! Clearly, the answer that you seek is you're wrong and I'm right, and suck it up. But unfortunately, it's me that I am saying to you that is what it is. I'm right, you're wrong, suck it the fuck up. Why would you harass a person trying to claim bullshit about you? I don't know. Why would I do that? Am I harassing them? They're not here. Why don't they go suck it the fuck up? Yeah, but that was the end of that. Like the actual end. Because basically nobody really gave a shit about that I made. Because to make it really, really simplified, there wasn't a way to turn it into anything with an internal combustion engine. And the use of like really rapidly accelerated air was a bad idea for any like ground vehicle. And then turned even worse for like electromagnetic, type of motors because it couldn't be used in like almost any aspect for how we actually currently use them. And so it was like, well, neat trick for, and then I was like, hi, so how much you gonna not pay them and go with me for all of your shipping concerns? Do you think that they're good? Because they're not. They didn't like me very much for a while, for its worth, but I didn't really care that much. It was pretty fun to watch them just fucking all get slowly consumed. I called myself not a monopoly because it's true. I have multiple other corporations and companies underneath me, and so I'm not. And I only own like 95% of it all. But it worked. Look at this. There's a ginormous tanker in the cargo ship. It basically runs off of light and some fucking like blimp. It's very little fuel I ever use. You will pay me this amount for that. Of course I will. Meanwhile, hey, so what's the size of this bastard? Holy Lord. I'm not even kidding. I ended up setting up my own, like, what are they called? Airport or airfields or whatever. And I ended up just making a genuine effort, I guess, at this point to make the highest altitude, largest aircraft ever built, I suppose. To put it in perspective, it's 5 miles wingspan for one wing. Yes, what the fuck? Yeah, but it's basically just one wing. There is technically a fuselage, so I have to consider it two wings, but you know. Oh, that sounds dangerous. Well, you know, for someone other than my level of incredible, amazing amounts of technical skill and ability here, it was nothing. Truthfully, it was a shit show to make these fuckers. I have like a few hundred of them, and they all run like everything. I make more money doing that because, well, for one thing, it's like not as expensive as I only run during the day, and it's effectively as cheap as it can be, and I can ship about 3 cargo ships worth of material constantly throughout the day because of it. Because I have a huge buoyancy factor and lift characteristic. So it was like, Mom, the sky went away. It's just someone shipping something. Honey, it's okay. It's transparent though. Yeah, that's definitely not helping. It's not. You see, like, this fucking beast ate a bunch of freaking boxes of shit. It's just flying above you. It's just everywhere. They're everywhere. That kind of thing basically happened. It was pretty funny, briefly, and then I realized it was actually kind of serious because people really did actually freak out. Because there have to be lights and stuff, and you know there has to be like ways of like knowing that it's an aircraft, and man, does it just make it look more alien every time I added the necessary required things to it. There's like people in there. I swear. Yeah, I'm sure. Yeah, that was a whole other airliner mistake. It was like, ah, yeah, I'll make an airliner. It'll be so cheap and blah 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 and better for the environment because I basically use literally no fuel. It'll pay for itself so fast. Yeah, what happened? Uh, well, so people are jerks and take advantage of shit. It's like you're basically getting $1 to fucking travel halfway across the world in a couple of hours, bro. They're like, I'm complaining that there isn't like blee 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 blee. I'm like, dude, there's like a fucking hell. They thought it would be like some fucking airliner cruise thing, you know, like you go in the ocean or something. And it wasn't that. It's like, this is just a passenger airplane to get you from point A to point B, you know? So instead of like, I get to sleep in my, you know, nice little room or whatever, it's like, no, you're sitting in a fucking seat. Like, yeah, I know you have leg room, you got head room, you know what I mean? Like, that's going on, obviously, right? Like, you got an upper and lower and all that. You got the wing area too, and so on. But it's like, it's bright up here. Well, fucking no kidding. Oh, God, I hate them. I hate them so much sometimes. They say things and they're annoyed. As if they didn't just pay $1 to go to fucking Australia one day from British Columbia for some reason. Just like hopped on an airplane today, went to Australia's. Hi guys. It took them 6 fucking hours. I'm complaining that it took 6 hours to get here. Oh, really? It's only 6 hours, is what we would have said back when we were your age. Took us fucking 24, 36 hours with some layovers and change, unless you wanted a direct flight, which was still taking basically a day or more, because it's British Columbia, Canada to Australia. So it's like, I'm looking at them like, what the hell are you fucking on about? Really? You're angry about that? Are you really, like, actually, really, are you really? Do you even understand? The 6 hours means I'm a hypersonic craft that's 10 fucking miles wide of a wingspan with a fuselage in between, which is still pretty big, still, you know. Why do you have it so big? Because most of the things are in the wings. Yeah, it's like there is a fuselage, but it's like that's really only there so you can go into the wings. They're always so like stupid and so pissed. How come people get to see my luggage? Well, you'll know that it's definitely been checked in. That's good. Yeah, no positives ever. You're such jerks. Not even kidding. I hate it. I hate this shit. After a while, I shut it down. It's like just cargo now from now on. Just like, fuck that. It was, look, we had great employees. Seriously. Wonderful pilots. Great employees. All of that. Never had a complaint on that. And I mean that because we watch everything, of course. That's, I mean, remember the whole airplane with the whole point was it was supposed to be what is effectively a signal hopper and its own version of like I'm internet for anywhere. Well, yeah. So then, basically, I can see it always, and it's always recorded. There's bathrooms, and they are closed off. You can't see in. Stop it. Why are they so weird about this? I don't know. You're such a weird people. Humans sometimes. You're one of them. Yeah, but I'm not that one. Or any of them. And they're weird. You know what I mean? So, but I moved on after like a bunch of incidents of passengers clearly trying to sexually assault and or harm my, flight attendants. And I was like, I'm out. Yeah, you guys don't deserve that shit. This is bullshit. It's not even a joke. That's like literally where I ended it. Because first and foremost, it was like, what am I doing? I'm giving you $1 to go to anywhere in the world, basically. I think it's like literally $1 no matter what, because it costs next to nothing. And we could ship, or fly people, ship, fly, whatever. Like close to 10,000 people at once somewhere. Close to? Yeah, well, it was more close to 30 if I really wanted to make it like that, but I didn't do that. I was like, here's a nice place for you to just sort of stand around and look at the beautiful view through the wing. Yeah, right. There's a movie theater area. Is it really actually though? Yeah, well, it's kind of a combined thing. Combined. Yeah, yeah. This room, that room, and then they synchronize. They play it together, but you can hear kind of thing. Right, right. Yeah. They're pissed. Yeah, I don't know why they would be pissed about a guy that made it so they could fly anywhere for $1, just getting pissed about them being shitty fucking customers and passengers, just deciding to no longer do it anymore. I don't know why. I mean, the shitty people would definitely just agree they were being a little too shitty and, you know, take it on the chin for what it's worth, move on, not believe that they are entitled to anything. Turns out that's not what the case was. Not even kidding. There was a couple of them that were rich that were like, I'm gonna go sue you. I'm like, we don't exist. Sorry, I don't know who you're going after. I'm not even kidding. I got away with that, doing that so many times until eventually they fucking found me in a actual country I had to make to try and, you know, just get around certain stupid laws and restrictions in regards to like allowance of no fuel on a plane. I have some batteries, I have some freaking props and stuff. More than good enough for everything. But it's like, no fuel mean danger. Well, my country says that it's not that, so deal with it. Not even kidding. They still found my ass for other things. I was like, what is this about? Distress about no longer having the ability to fly as cheaply or with you. He's in jail for assaulting my flight attendant. No, it's a whole thing, yeah. That was a real one. The judge approved that. I had to go fucking deal with it. They served me in another country. Legally, I'm another country, yeah. Bullshit. I was like, my country over here says fuck off, no. Their country over there goes, well, I guess. I don't like America much sometimes. There are other ones that are very similar to that. For what it's really worth, it's not even a joke. Most of them are almost kind of the same exact thing. Like, emotional distress of the students based upon no longer being able to go to my jobs because I can go to any other airliner to afford going to my country for where my job is. I was genuinely so upset about that one. I was like, you're upset about not being able to go to your job because you relied upon me. Just gonna take a look at all their flights here. Oh, you were a jerk that got drunk and then tried to fucking like manhandle one of my flight attendants, you bitch ass woman. He's still trying to find you. Thanks for contacting us so we have your information so we can charge you. They still had to proceed forward with it. They actually put that one through too. And I was like, this is bullshit. I'm not bringing the passenger aircraft stuff back. You're not going to try and sue me or do any of it. And then I literally sued the United States government for defamation in many aspects. because they were putting me through a bunch of sue-happy court cases that were literally of no merit or value. All to just be like, how come you won't give it back? Give us back our cheap flights! I didn't defame them. She's like, you're literally ruining my country, companies. My country was never, I didn't give a fuck what its reputation is. But it's like my company's reputation in me as a person and all this shit is that, man, did they get rough online. So many of them just got like so fucking up their own emotional reaction to having butts for so long about it. It's like, dude, you can't just give us like a fucking dollar to go anywhere and just take it away. Yeah, I can. Nothing says I have to keep it going. Deal with that, please. They're like, you're destroying the economy. So you know all of those companies over there are really bad companies and should change. That's what I just heard. Not even kidding. I got so deeply inserted into the fucking like whole government system after a while because like it was bad. It was so bad. Like so many people started getting in on this shit. And it's like, why are you suing us? Because you defamed the shit out of me. And then it got into a whole bunch of other things with how it is a naval, this amendment stuff started happening. Went to the Supreme Court. They ended up siding with me. They owed me like a couple of $100 trillion for lost potential earnings. By that point, I had already proven I was basically unkillable. I lopped off one of my legs and regrew it back. I stopped my heart and continued running. Shot myself in the head and continued running around. So I was like, here's my biologic immortality, bitches. That means I'm gonna live for a really long time. Guess who's going to 100 trillion plus? That was just me personally. The United States government owed me. Not even getting into what my company was owed, which was even more. They were like, here's the keys to all of us. I was like, I can't use this, and no. Kind of would rather you just pay me installment. Oh, fuck, you just raise your debt ceiling all the time. This is so bad. You know, it's like 10% is the bare minimum that we could maybe do. And I'm like, I'd actually really want to look into that. This motherfucker read, like, or posted on Reddit, you know, like, what are scary facts or whatever about this, like, debt problem that we're having. And I'm like, well, there's a whole bunch of shit that I'm like, yeah, but they don't care, corporations, about us no longer having a job or this or that, or playing with our financial futures with the stock market booming and busting. So I don't see why I should give a shit about them. And I don't really see why politicians should be, we need to not cut our overwhelming amount of money that is way more than an average American makes for the job I do. And he's like, no, I'm trying to be considerate of others. I'm like, no, you're trying to make me have empathy and sympathy for basically a bunch of people that take advantage of the entirety of the people that put them there. And he's like, 10% or something, right? And I'm like, 10%? You're a multimillionaire, bitch. You can handle this. think we can do a little bit more. I think we can make it happen. We can't do blah blah blah. We can't do blah blah blah. We can't blah 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 blah. We can fix this debt. You just don't want to make sacrifices. You want to continue having massive amounts of goddamn fun and play and rich ass things and places. What, you wouldn't want to live in the SMI housing apartment that I live in? Huh, multimillionaire senator? How about you, Judge Sugar Babies? Okay. Hey, how are you doing over there? Person that's trying to pretend that they're an average everyday worker. Yeah, but not every. Oh, so you guys shouldn't get paid appropriately? Wonder if that debt getting met would allow for them to say to you, the average everyday worker that works for these things, called Social Security, Medicaid, and more, would have more of a fucking fight and power to their voice to have a better wage. Maybe I seen how this was bullshit, this post. But then I also understand why they're doing it. Yeah, no. It's like, come on, guys, gotta work together. I'm not giving them the consideration that you want me to. They are gonna have to make sacrifices, as I'm literally gonna just be homeless if I don't have this, and they can make a lot more sacrifices than I can. They got themselves into this mess by raising a group of ginormous, moronic imbeciles who are tribalistic garbage selves of who they really could be. Immature, emotional, reacting, non-critical or logical thinking, no perspective-based thinking, enabling gaslighting, and more terrible people. And they all helped that to happen. So you're going to have to take responsibility, even if they were like, I wasn't here before. Well, you were a part of it before you were even in the government doing those things. So, huh? Yeah, but they don't like that. Yeah, I don't care. That's the point I'm trying to make. I don't care. They'll have to figure it out. I'm not the one to figure their shit out. See what I'm saying? Alrighty, so we're gonna move on to the. I was gonna talk about how you can put three of those like toroidal parts together. So like you clamshell the two. Well, if you make one that spins the counter-rotate end and the other two spin the same way, right? Then what that does is allows for one to have two sides that are like the your main like thrust or something. Anyways, point is, it allows for that to have more torque. It's like it has more displacement because it has more of those arms, more all that stuff. Even though it's still toroidal, like the donut area where they stick together. Even though this is in between, it's still 49cc. But because I got two around the center, I got even more torque, displacement, technically. It's not really displacement. See what I mean? It's like the cylinder is born stroke. It doesn't matter how many pistons you throw into it, and I can put 12 in there. So if I have two on either side, they go after one, I have 12. But then it's like, right, but then I also get like an opposed piston with the center. So it's like those two rotate and this one rotates. And so now I have an opposed piston. Cool stuff, right? I just didn't really want to do it mostly because it was like it's technically getting around like torque, I guess. It's more efficient for sure. It's a little bit more difficult to make because then it's like, well, how the hell does it stay in there? You know what I mean? Like I have to stick this with like a mushroom tip into this thing with like the top part area, being the toroidal, uh, to like have it situate underneath, clamp to it. It'll work, but it's like, or do. So, bye.